Now I would like to see what is happening under the hood of OSPF. So I'll just start this OSPF one more time. On R4, I'll use the network method to enable OSPF on the interface. I'll say network 10.1.45.4 with all 0 wildcard mask, and it'll operate in area 0. For now it's just area 0. I'll tackle multiple areas later. But before I hit enter, actually, I'll enable some debugs maybe. Do debug IP OSPF packets, hello, and adjacency. I'll do the same thing on both ends of a connection. Do debug IP OSPF packets, hello, and adjacency. Now I will start process on both router OSPF1 and router OSPF1. Once we have a router enabled, let's just clear the terminal. Let's start OSPF on both interfaces, and I'll use, like previously, two different methods. So on R4, I'll say just network statement 10.1.45.4, and I'll pinpoint this particular interface to start sending hello packets, area 0. Before I hit enter though, I'll prepare quickly R5, and this one I'll just jump to the interface 45. I'll say IP OSPF process 1 area 0. So two different methods of doing the same thing, of sending hello packets, trying to discover neighbor on those interfaces. And now click enter, enter. Let's see what happens. Okay, let's disable debug. Do you all do you all. Oh, let's scroll back up and see what happens. So I enabled OSPF first on R4. Let's see what happens here. So this is the network statement. I hit enter and see adjacency interface going up. Hello is sending hello. Now OSPF uses two multicast addresses for communication. It uses 224.0.0.5. This is known as the all OSPF router ID, address multicast. And there's one more, 224.0.0.6, which is the communication between DR and BDR. We'll get there shortly. So receive version 2 type 1. OSPF uses 5 type of packets. Is hello, it's type 1, DBD type 2, link state request 3, link state update is 4, and link state acknowledgement is 5. Area ID, router ID, okay. Received hello from the other end. Okay, so upon receiving hello from the other end, the router immediately sends its own hello, and in that hello, it'll put the ID of the router from which it received hello as its neighbor. So when that happens, let's go 5, scroll back up here. Upon receiving that hello, where 5C itself as the neighbor ID in the router ID field in the hello, it says okay, two-way communication, state two-way. That means that I saw you and you saw me. We saw each other in our respective hellos. Next, so the first state we see in the debug is a two-way state. This is indication that they saw each other. So let's see what two-way communication state here is. And then the routers proceed. So now it's like a 40-second time wait timer when they wait for the communication from designated router and backup designated router. What those roles are a little bit later, but for now let's just focus on what happens here during the initial start. So end of wait on the interface. Okay, here end of wait on this interface. So we already know there's no designated router and backup designated router. So the routers will select one designated router per segment and one backup designated router per second. Again, what those roles actually mean a little bit later. For now, let's see that election. So elect BDR 555, DR 555. Now, the DR designated router on the segment becomes the router with the highest router ID. 5555 is higher than 4, so that's why it becomes the designated router here. So for now, this guy thinks R4 that both roles are the same box. And now neighbor P5555 will be preparing the database exchange. This is a link state database protocol. So they will exchange information about each other and what they know about networks. They will confirm them. So this is a type 2 DBD exchange happening right here. And we enter the X start stage. So upon selection of DR BDR, we exchange start begins, in which actually we'll come back to it later. At this stage, the routers will check their respective MTUs and they must match. So there will be actually, in order to accomplish the two-way state, there will be 5 things checked. The hello and dead interval packets must match. They must be on the same subnet. The area ID number must match between them. The area type must match between them. And if there's an authentication, it has to be the same type and the same password. If they all have the same parameters, they will declare themselves two-way. And then they start this exchange. So each one of them will describe the networks it knows about, but the details are not sent at this point yet. So what happens is X start and negotiation of slave and master. So master will be dictating what the LSA numbers are going to be during the exchange and who's going to do this first in orderly fashion. Once it's done, receive DBD from this. We'll send a request, the link state requests. We get further information about the networks we don't have. So once I receive DBD and I don't recognize the network in my database, I will send the link state request, send me more information about this network. And we're receiving those. Upon all this exchange, we are synchronized here. That means that I know your networks, you know my networks, and the loading full is accomplished. So this is where we are actually now done. So there are 3 distinctive states. Actually, one is missing, which is very hard to capture using debug, which is called init, initialization state, upon which when we send the packets, we begin to exchange those packets, hello packets, checking those parameters. If they are okay, we accomplish two-way state. So upon exchange and everything is okay, we get two-way. I saw you, you saw me. It starts to exchange another messages and we go into X start state. Once we do that, we need to agree who is going to be the designated and backup designated router. And when that negotiation is done, they elect master and slave, who's going to be the master during the exchange. So it happens in orderly fashion. Exchange starts, then in which we exchange DVDs and we ask for specific information, link state request. And updates are received, and then if everything is exchanged and acknowledged, we get into full state. So under the hood there's quite a lot happening, but once everything is okay, it accomplishes the full state, in which we see this do show IP OSPF neighbor. On the broadcast link there's neighbor 5555 whose role is designated router. We'll talk about that later. And the state is full. So on both ends we see the same output, except for DRPDR, do show IP OSPF neighbor. We are in a full state, and 4444 is a backup designated router. So all is good at this stage, And in the next video, I'm going to actually break things up to do some troubleshooting of this adjacency and see how the router reacts in the debugs when things are misconfigured.